Hello. All right, here we go. We're going to do a little science experiment or a little demonstration here for you about the conservation of matter, or you can call it the conservation of mass. Remember, mass is how much stuff is in something, right? So that's the amount of matter, the amount of stuff. So everything has a mass amount. I have a lot of mass, right? I'm big. You have a little bit of mass because you're smaller than me. A little tiny mouse still has mass, but it's a lot smaller than us, right? So this week you've been reading about conservation of matter. You watched some videos about it, and it's basically saying that stuff, no matter what, it's not going to change. Matter can't disappear, so it's going to go somewhere else. It's going to be a solid, a liquid, or a gas. It can change forms, but it's never going to disappear. Okay, so I have a bunch of stuff up here today. So we're going to do a couple of different ones. The first one, I just want to show you real quick. I have a scale here. I know it's kind of hard to see, but I have a scale here. Has the numbers. You put the stuff on top of this here. But basically, if I take this pencil, okay, nice normal pencil, and put it on here, I'm getting a reading of 8 grams. Okay? 8 grams. Now, if I take this pencil and break it, now it's 2 pencils. And if I take it again, I need to work out more, and break it again. Now I have 3 pieces. What do you think the mass is going to be now? It was 8 grams before. So, still 8 grams, even though it's in 3 pieces. So, what that's telling us is the mass or the matter is conserved. It's saved. It doesn't go anywhere. Just because it's in 3 pieces doesn't mean it weighs more or weighs less or has less mass or has less matter. It's still all there. Now, if I took a piece away and threw it out, now it's only 6 grams, right? Because it's not part of it anymore. We took it away. But if we go get it, my pencil, still 8 grams, okay? So even though it's broken up into 3 pieces, still weighs the same. Still got the same mass, okay? Same thing, this envelope, 6 grams. Put all the pieces back on. Guess what it is? Still 6. Okay? Still 6 grams. All right? So that's what this is talking about. Stuff that's not going to go away. In this case, those are physical changes. I was just ripping it up. But what about boiling water? Right? Where does that water go? You can leave it on the pan. Where does it go? We see that steam go up. Now it's a gas, and it'll disappear. Okay? So if we could catch that, we would know that it's still there. It just changed forms. Okay? So what we're going to do now, I have some different materials here. Okay? First of all, I have a graduated cylinder, a Big Daddy. All right, this is just to measure liquid and things like that. Right here, I have a big thing of vegetable oil. So I'm going to pour this in here, just so I can make it easier to pour. So we're going to use this later. This is just oil, right? Cooking oil. Right here, I have my glass bottle, or my plastic bottle. Real quick, let me go get some water. I'll be right back. And I'm back. All right. So here's how we do this. We're going to make a lava lamp, or a fake lava lamp, and learn about conservation of matter together. So the first thing I'm going to do, I'm going to take this, and I'm going to just pour some water into here. Very scientific-y. Okay. Let me see. A little more. About a quarter of the way through, okay? So about 1/4 of the way up. All right, there it is. All right, so I got my water. Now, I'm going to put some food coloring in, too. I'm going with blue today, all right? So this is just so we'll be able to see it and make it a little more pretty. So I'm going to put some food coloring in there, okay? A couple more, why not? It's pretty. Pretty. All right, food coloring, got it. All right, next, I'm going to add the vegetable oil, okay? So I'm basically going to fill this up the rest of the way, okay? if you notice already that the oil and the water do not mix, that's because they have different densities. You'll learn more about that from Miss McGriff in 6th grade. Actually, I'm going to add a tiny bit more in here. Pour some in here. Don't want to get this oil on my new shoes. You guys know how it is, right? So I'm going to fill this up the rest of the way. And I'm going to stop there, okay? So now, if you look what we got, it's pretty sweet looking. Ooh. Oil on the top, we got our water and food coloring on the bottom. All right, now, what I have here is 2 Alka-Seltzer tablets, all right? These are like fizzy tablets. These are like, you can use them when you have a cold, you can use them if you have like heartburn, or old people or adults use these. If you don't know, ask your parents or ask your grandma or ask somebody. These, you can drink them when you have, like I said, they make your water all fizzy and you drink it and it helps you feel better, right? So we're going to use it to make some bubbles or some chemical reactions in here, all right? Well, how we're going to do it, we're going to catch it. Like I said with the water, like it's going to release, right? If I let go of gas, where's it going to go? Into the sky right now. If I do this, it's going in the sky. If I do this, now I caught the air, right? So if I could weigh this, right, my air would have mass, because look what it's doing to the balloon, right? But if I let go of this, all the air is gone now, right? So what we're trying to prove is that even though when I put these in the water, they disappear, right? You're not going to see them. They're going to dissolve. Well, that doesn't mean they're actually gone, okay? So what we're going to do is we're going to take the mass of all this stuff, and then we're going to drop these in and watch them disappear and see if the mass is the same. Okay, and see a cool little thing what happens. So, I'm going to put 2 tablets on the scale. Okay, 7 grams. I'm going to add the water and the oil. We're at 932. And I can't forget, I got to add my balloon. Actually, I'm going to go and use my light blue balloon. No, I'll use my balloon. Okay, so I'm going to put that on the scale too. So if you look down here, I got it all on the scale. Okay. Now, there it is, right? So that's all of our stuff. So what we're going to do, I'm going to kind of zoom down here so you can see. So I'm going to take this off. Oh, wait, I didn't see what it was. 934 grams. Okay? So I'm going to take this, and I'm going to take this, and this, and I am going to put the tablets in, and then we're going to watch and see what happens. But when I do it, I'm going to put this balloon on top, okay? So we're trying to trap the gas, all right? We're going to trap the gas that comes out. That way we can prove that when I put it back on the scale, even though these will be gone, it'll weigh the same, all right? So here we go. I'm going to break them in half just a little tiny bit so I can get them in there. And then I'm going to try to hurry up and put the balloon on, right? So here we go. Just drop it in. Catch it. Hopefully. All right. So you see it bubbling, lava lamp. Yep. Pretty sweet, right? So you can see, look at the balloon too on top. It's starting to catch some gas here. So you can see all this going down here. All these are reacting. You can see they're bubbling, going crazy, making our water and oil mixture go at it. And look at our balloon on top. Okay, it's starting to get a little, starting to get some gas in it, right? So we're not going to catch it. We're catching it here. We're not letting it release. So I put this back on here, even while this is happening. Guess what? 934 still. Okay, we caught it. 934. That's conservation of matter, guys. Even though they dissolved, you can't see them in there anymore. Still 934. All right, so our lava lamp's starting to die out a bit. If I put some more in there, it would bubble some more. but it would also add more mass. So what I was trying to prove to you is no matter what we do, if we can catch it and keep it on, no matter if it changes form, it melts, it stays in here, it dissolves, we still have it, okay? And the final thing, if I did this and took this off of here and released our gas, all the gas would disappear. So now our mass is going to change, right, if I let it go. And it just went down 1 gram. So I had 1 gram of gas caught in here, keeping it in here together. All right, so guys, conservation of matter means no matter what you do to it, as long as you know you keep it all contained, no matter if it changes form, it changes shape, you take your Play-Doh and put it into 100 pieces, still going to be the same. Put it in one big ball, still going to be the same. We dissolve that in here, it was still the same, right? Because we trapped it, it's all in here together. So matter or mass does not change unless you absolutely destroy it, which is not possible. All right, if it's a chemical change, that's a different story. But what I want you to focus on here is conservation of matter means that no matter what, mass is conserved. All right, you can tear it up in a million pieces, you can dissolve it, you can put that Kool-Aid in your water, it's still going to be the same. It's still going to have mass. Okay. All right, hopefully that clears stuff up, and hopefully this was kind of cool looking. My next post, if you look underneath it, it's how you can build your own. All right, so enjoy, and I'll see you later.